Okay. So we're starting with power and square roots. For each power, identify the base, identify the exponent, and evaluate the power. Okay. So I think I talked about this a little yesterday, but oh, and on the side here it doesn't actually show it, but it's not a big deal. The base is always this sort of major number. Okay, and then the exponent is always what's that smaller high number. Okay. So it looks like this. If that was x to the y, x equals the base, and y equals the exponent. Okay, right. Okay, so if we're identifying base and exponent here, I'll just go base equals, in this case, 2. Exponent equals 3. And you just use your calculator. Remember, it's sort of that little triangular hat button. It looks like this to do your exponent, or it's the xy. Okay? So in this case, to calculate 2 to the exponent 3, I'm just going to go 2 to the little hat. 3 gives me 8.
Carrie, can I call the office, please?
Does this make sense?
Yeah.
Okay, what I'm going to do is I'm actually just going to put the base and exponent down here so that I don't have to rewrite. So here my base is -3. Make sure there's a bracket around that because it's actually a 3 that is negative. It is not a subtraction, what have you. That bracket tells us that if it was an even number exponent, it'll become positive, right? And if it's odd, it would become negative. So you need to make sure you know that. And here our exponent is 2. So again, use your bracket buttons on the calculator. Bracket -3 to the exponent 2 will give us a +9. If you didn't use your brackets here, it would give you a -9, and that is incorrect. Okay, that's the next example we're looking at. So base here is -3. Exponent is 2. However, that negative just makes your whole answer negative. So you end up getting -9 as your answer here. Okay? Base for the last one is 3. Exponent is -2. Just use it. Use your information. We're going to talk about negative exponents a little later, but right now I got 0.111111. Put a dot over that to show that it's repeating, even though it looks like an I. Pardon? Okay, I'll help you in a second tomorrow with the actual calculator part, okay? Remember, in this case, you're going to go 3. Nope. 3 to the exponent, which is this button here. -2. Oh, I changed something on your calculator. 1 second.
Oh.
On your, can you do something for me?
Yeah.
Hit, oh, 1 second, I'll do it. Hit second plus 712. And it should say RAM cleared.
Yeah.
Okay, you're good. It should work now. Try it. Because I took decimal places off on your calculator. Okay, next, determine the value for x. So this is a bit new. This is a bit new. A lot of students just do trial and error here. They plug in different numbers for x to get to 27, and then they say x is that value. But really what you need to be doing is you want to get everything to a common base. So the 3 can't get any smaller, right? Does everyone agree 3 can't get any smaller? But what I want to do is I want to go 3 to the exponent something and try to get to 27. So if I go 3 to the exponent 3, do I get 27? Okay, so instead of writing 27 again, I write 3 to the exponent 3. As soon as those bases are equal, I can say therefore, and I can set the exponents equal to each other. As soon as the bases are the same number, I can say therefore my exponents are equal to each other. And then sometimes there's going to be some algebra there that you need to solve for an unknown value. Okay, so let's just keep trying. 7 can't get any smaller. I'm going to just switch colors so I don't mess up the... So 7 to the exponent x stays that. 7 to the exponent something. Can I get 7 to the exponent something that'll give me 49? 7 to the exponent 2. As soon as my bases are equal, I can say therefore x equals 2. Again, I'm just switching colors to keep the questions separate. 10, I'm not going to make any smaller, but I'm going to say 10 to the exponent what gives me 10,000? 10 to the exponent 4, perfect. Again, as soon as my bases are equal, I can say therefore x is equal to 4, because I'm saying x, the exponents are equal to each other. Okay, and last one, I'm not going to make 5 any smaller, and I'm going to say 5 to the exponent what gives me 3,125. 5 to the exponent 5 does. Therefore, x is equal to 5. Again, sometimes in the exponents, you're going to have multiple variables or multiple terms that you'll have to solve. This is new. You will not have seen this yet. Okay? This is new. Yes. I can't think there's any. I'm trying to think if there's any that are fractions. They're generally all whole numbers, especially in this course, right? Okay, next. So now we're just taking the square root. So really most of this stuff is just making sure you know how to use your calculator. To do the square root on the graphing calculator, you can hit second function, then is 1, 2, 3, 4, 5 buttons down. We'll hit square root, 36. A lot of these square roots, you're just going to get used to knowing what they are. Okay? Make sure you can figure out what these are, because that tells me whether or not you know how to use your calculator properly. It's not, this isn't really what we're doing. It's like preparing you to get there, to get to the next step. Yeah. Okay, here's my next question. Do you notice something? The square root of 36 is 6, right? What is 6 squared? What is 6 squared? 36, right? So squaring something and the square root of something are the opposite of one another. The same way multiplication and division are the opposite, squaring something and the square root are the opposite. Okay, we've done that before when we were doing algebra at the very beginning, and we need to eliminate a square root or eliminate a square. Okay? All right. I use the calculator to evaluate each expression to 1 decimal place. You guys just follow, so check my answers, right? Square root of 30. I got, how many decimal places? To 1. I would get 5.5?
Yes.
I would get 7.8. Yeah, B? Okay. Stephen, did you do it? Okay. Did you guys get 9.0 for C then? Okay. Okay, B, I got 7.8. Okay. Thank you, Demar. And for D, I got 11.2. Okay, awesome. Okay, again, this is just square root, right? Just square root, no big deal. We can do cubed roots, we can do all of these other things, but this is just squared. Okay, write each expression as a single power, then evaluate. This is not a big deal. Exponent laws are on the right side board. Yeah? Okay, so multiplication, as long as the bases are the same, you add the exponents. Division, you subtract. There's one called a power of a power, where they're in a bracket, you multiply. And then there's something called the zero exponent rule. If there's an exponent of 0, it becomes 1. Okay, so let's do the first one. I'm going to go 5A. I'm going to go down a little farther on the screen so I have space. I'm going to show multiple steps. It's really for people who aren't here today, and if you guys want to show it to get more marks, just in case you mess up somewhere along the way. Okay, so 5 to the power of 2 times 5 to the power of 3. Are my bases the same?
Yeah.
Is it a multiplication question? So it becomes 5, 2 plus 3, which equals 5 to the 5. Everyone agree with that? Now it's actually saying to evaluate on this question, so I'm going to go 5 to the exponent 5 gives me 3,125. Evaluate it actually, yeah, it actually wants you to calculate that exponent. Okay, next. 5B. Don't do 5C first. 5B. We go left to right, remember?
Did you always want us to show our words?
So this is it. Do you need to show, well, first of all, you have to show this step, and you have to show this step because it's asking for a single power and then evaluate. So this is important, and so is this step, okay? The middle step where I'm showing addition, if you don't show it and you get it right, it's not a big deal, right? If you don't show it and somehow you add the numbers up incorrectly or something, I can't give you any part of this. So the more you show me, if you ever got into trouble, the more I can help you, okay? Again, the next question, 5B, bracket -2, bracket -2. So my bases are the same, and it's multiplied, so I'm going to add my exponents. So I have -2 to the exponent 8. Remember there's a bracket around that, and I am evaluating. So bracket -2 bracket to the exponent 8 gives me 256. Everyone agree? Yeah. Okay. C. I'm just rewriting them because I don't have the space. Okay, this is a division question. What's the rule with exponents when I divide? Subtract, right? So my bases are the same here, so now it's going to be 7 to the 5th minus 3 equals 7 squared, 49. I'm just going to stick it there. So equals 49. When, pardon? You multiply your exponents. Yeah, it's called a power of power. So 5D, this is a power of a power. Again, it is up on that sideboard. What happens with the power of power is that the two exponents get multiplied. Okay, the two exponents get multiplied. So now I'm going to have 9 to the 6th. This tends to be the one that is done the most poorly, and it's because people automatically add the exponents and they're not thinking. Okay, so just be careful with this. So 9 to the exponent 6 equals 5, 3, 1, 4, 4, 1. Okay? Everyone okay with these? Yeah, it's also on the side. All of the exponent rules are also on the top side of your page. Okay? I don't know if it's on the formula sheet.